What's that? Oh, really? All right. Well, good morning, everyone. Welcome back to another exciting day of mathematics. Warm-up number 24 is on the screen. Let's get started, please. It shouldn't take you long. And yeah, I like the creative aspect of today, which is anything but a backpack. Is that a toolbox? Nice. Earlier in my first period, I had a student, one of my seniors. He walked in with a little person, little sister carrying all his stuff. I was like, what? And she stayed, and she was taking notes actually during class. I was like, okay, yeah. Anyways, I'll give you some time for that. Copy and go. All right, so if you notice, numbers 1, 2 is stuff that we've been doing like forever. Numbers 3 and 4 is practice of what we did last week. And I don't know if you noticed, number 5 is something kind of new. It's something that you've already done in the past, but I'm bringing it in because we're about to head in that direction. So, with that said, share with your neighbors, see what you got so far, and then I'll get us started, get the show on the road. All right, here we go. Number 1. If you guys notice, there was multiplication. What you get for number 1? Let's start with Jaden. What'd you get?
Oh.
Let's go. Oh, my bad. Let it go. Let it go. There you go. All right, hands if you got that. Close. You're like, what? No. So far you got it right. But some of us forgot one tiny little thing. And I'm bringing it in now. Who remembers, look up to the screen. Let me pause the tunes back there. Who remembers that at the beginning of the school year, I introduced the different numbers? You guys remember that? Yes? All right, good. So, some of you forgot about this piece, though. Ready? Here it goes. Let me refreshing your memory. Remember we did square root of 16i? I'm my bad, not 16i. Square root of negative 16. Negative 16. And we said there is no such thing because of the negative. Is that correct? How could we rewrite that? Square root of negative 1 times 16. Is that correct? And then from there, square root of negative 1 times square root of 16. So far so good, yes? So what is square root of 16? That's 4. And what is square root of negative 1? We said that was what? I. Okay, now check this out. I'm going to add one more thing to it. Why I? Because there's no such thing. This is known as imaginary 1. Okay? So, question. Y'all ready? So, what is I? Well, I is square root of negative 1. Yes? Okay. What if I wanted to get rid of this square root right here, guys? What can I do to get rid of that square root? I square it, which means I square this one as well. So if I square that, this cancels. We're left with I squared equals to what? Negative 1. So from now on, pay attention to this part. Anytime you see an I squared, what are you going to substitute in there? Negative 1. Copy this on your paper, please, that piece. I'm introducing it slowly, but surely we're getting there. So once again, How do we get to I squared equals to negative 1? Well, we started with I equals to square root of negative 1. To get rid of the square roots, you do a square to both sides, and that's how we get I squared equal to negative 1. So with that said, so everybody should have gotten this so far. So, next step. Do this next step with me. 10 parentheses, negative I plus 21. And instead of I squared, what am I going to substitute? Negative 1. So, what is 10 times negative 1? Negative 10. Bring down the negative I plus 21. So, what is 21 minus 10? Everyone? 11. And bring down the negative I. And from now on, leave it like this. Whenever it involves I, put a little hashtag or asterisk and a heart. I always goes at the end. The I always goes at the end. Why? Because we're about to get into compound numbers, complex numbers. All right? Whew, that was a long one. Let's go to number 2. This one had a subtraction, so we know what to do with that. Therefore, Jaden, pass someone for number 2. Brandon Felix, what'd you get for number 2? Minus 2x minus 3. Very close. Negative 3. Hands, have you got that? That is correct. Good save right there. All right, so we got number 1, number 2. Let's go to number 3. I'm going to do number 3 and 4 expeditiously, just for the sake of time, because we have a lot to cover today. Here it goes. Number 3, this is a recap for all of us as to what we did last week. What are the first 2 things that we checked? Standard form and GCF. Is there a GCF for these 3 terms? Yes, it can be divided by 3. So we're left with x squared minus 9x plus 20. From there, what goes on top? The 20. What goes underneath? Negative 9. Therefore, what 2 numbers multiply to give me 20 and combine to give us negative 9? And we said negative 4 and negative 5. Hands that you got up to right there so far? Okay. Next, we rewrite this, bring down the x squared, bring down the 20, and instead of 9x, what am I going to write? The 4 and the 5, so negative 4x, negative 5x. So far so good, yes? Danny, you good? All right. Then we get to the grouping. First 2, last 2. So what is GCF for these first 2? What is the same here and here? The x, we're left with x minus 4. What can divide these 2 right here? 5, but this one has a negative, so it's negative 5. So we're left with x minus 4. Therefore, let me make some room here. What is the same here and here? Well, x minus 4. And what is left over? X minus 5. Am I done? No, our BFF. Who's our BFF? The 3. So these are my factors. How many? 1, 2, 3 factors. How are we doing? Good? All right. Next, let's go to number 4. And you're like, wait a minute, Mr. Q. Let me erase this right here. How many terms do we have? 4. Question, is it in standard form? Yes. Is there a GCF? No. So what can we do with 4? Well, whenever you have 4 terms, we go straight to grouping by 2s. All right. Oh, So then put a little plus sign right there. So question, what is GCF for these two? What do both have? X squared, yes. So that leaves us with x plus 3 because we took 2 of them out, 2 of them out. Next, what can these two be divided by? Negative 1. Yeah, that leaves us with x. And then negative 3 divided by negative 1 is plus 3. Therefore, what's the same here and here? X plus 3. And what do we have left over? X squared minus 1. And these are my factors. 2 of them. All right. How we doing? Good? All right. And number 5. Let me go to number 5. Here we go. So it says, solve for x. I'm going to draw my line down the equal sign. I'm going to circle the x. What's outside of x? Well, immediately is the negative 2, but outside of that is the y, 8y. So to get rid of the 8y from this side, what is the opposite of a positive 8y? Negative 8y, negative 8y. We're left with negative 2x equals negative 8y, and then plus 16. And what do I do at the end to leave the x by itself? What is the negative 2 doing? It's multiplying, so what is the inverse? Divide by negative 2, divide the other side by negative 2 completely, and we're left with x equals, here it goes, what is negative 8 divided by negative 2? Positive 4y. What is 16 divided by negative 2? Negative 8. And this is solved for what? X. Students, two variable equations, students. We're headed that direction, so I just wanted to bring it in slowly. We're not completely there, but just to give us plenty of practice. Okay, we good? You're like, oh yeah, bring it, Mr. Q. On the Monday, I want a lot of math. Let's go. Copy these again. Warm up number 24, factoring polynomials, difference of squares and cubes. Today we're going to focus on that, and hopefully for tonight it's only 1 through 12 only. All right. Once again, warm up number 24, factoring polynomials. In the parentheses, I wrote difference of squares and cubes. We'll talk about that today. And then we have home play numbers 1 through 12 only. Here's your Nearpod code. Copy this. Q8P2B. 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 All right, get a Cornell note ready, please. There's a home plate for tonight. It's only 12 of them, only. You don't need a prayer model because we already know what polynomials are. Is that correct? All right, so our objective for today, I can factor polynomials. Before I move on, tell your neighbor the definition for polynomials, please. All right, Anthony D. Polynomials. Monomials or sum of difference of monomials, yes. And thank you for the videos that you guys created. Very artistic. Thank you very much. Some of you actually rapped through it. Was it in this class? In another class, I think they rapped through the video. Let's go. Right? Am I right? All right, so we got that. We did these, yes? These, these, and so on and so forth, yes? But we focus more on these, didn't we, the trinomials? Look at it. X squared minus 9x plus 18. Don't copy this. What are the first two steps? Standard form and GCF. Is there a GCF? No, so what number goes on top? 18. What number goes underneath? Negative 9. What two numbers multiply to give me 18 that when you combine them give us negative 9? Tell your neighbor, please. Two numbers that multiply to give us 18 that when you add them give us negative 9. Once again, if you're not fast at these, just remember, start making pairs. 1 times 18, 2 times 9, 3 times 6, and they repeat. Which one of those, if you combine them, become closer to 9? The 3 and the 6. And they both need to be what? Negative, and we already know the rest. Okay. Next, look up. Again, standard form? Yes. GCF? No. Then, let me pause that really quick. What goes on top? Negative 30. What goes underneath? 1. So, what two numbers multiply to give me negative 30? When you combine them, give us positive 1. So, let me show you the pairs. 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then they repeat. Look at those pairs. Which one comes close to adding or subtracting to give us 1? Tell your neighbor, please. What are they? What are they? Martin, which one? Five and 6, yes. 5 and 6. And for this one to be a positive, that means the biggest number has to be a positive. That means this one is the negative. Okay, not bad, not bad. Let's go to another one. Look at this one. Again, is it in standard form? Yes. GCF? No. All right. What goes on top? Negative 12. What goes underneath? Negative 4. So my pairs of factors are 1 times 12, 2 times 6, 3 times 4, and that's it. So which one of those, if you combine them, which pair give us something close to 4? Tell your neighbor what they are, please. Danny? 2 and negative 6. Let's see, 2 times negative 6 is negative 12. 2 minus 6 is negative 4. Yes, that is correct. And the rest is history, yes? All right. But then we arrive to this one. Copy this one, example number 8. 5x squared plus 8x plus 3. All right. Just copy it. I'm going to go over this one. This one's a little bit different. All right. Writing utensils down. Look up to the screen. Ready? All right, here it goes. So, let me go to the previous ones. Look up. Look at this one. Stay focused or you're going to miss it. Tell your neighbor what's so different about this one. What's so different about that one? What's so different about that one? Miroslava. What do you think, Miroslava? What's so different about this one from all the other ones that we saw? It has a 5 or a number at the beginning, a leading coefficient. In case you missed it, look up. Look at the other ones. Look at that one. Doesn't have one. Doesn't have one. Doesn't have one. This is the first time I'm introducing one with a leading coefficient. But you still check. Is it in standard form? Yes. Is there a GCF other than 1? No. So whenever you encounter something like this that does not have a GCF, check this out. Writing utensils down, look up. Look what I'm going to write on top. Ready? Tell your neighbor how I got 15. How did I get 15? Hopefully you saw it. What is 5 times 3? 15. That goes on top, and the middle term always goes on the bottom. Copy that, please. We're going to do this one together to finish off. And the rest is history. Let's see, pairs of factors of 15. 1 times 15 and 3 times 5. So which of those adds up to 8? 3 and 5. 3 and 5. All right. Help me from there. What do I do from there, Selena? Bring down the 5x squared, and then bring down the 3. And instead of 8x, what am I going to write? Let's go. 3x and 5x. Yes, that is correct. What's next, Courtney Jean? In 2 groups, yes, group and group. So, look at it. Tell your neighbor what would be the GCF for these two. Tell your neighbor, GCF for these two. GCF. I heard x, yes, and that leaves us with 5x plus 3 plus, what is GCF for these two, Anthony D? 1, that is correct, and that leaves us with 5x plus 3. Therefore, what's the same here and here, everyone? 5x plus 3, that's 1 factor. And what's left over for this one? X and plus 1, and that gives us x plus 1 is my second factor. 2 factors. So, tell your neighbor, what's the only thing that changed on this one from the previous one? Talk it over to your neighbor. What's the only thing that changes? What's the only thing that changes? Only thing that changes, Emily. Yeah, that if it has a number here, you multiply the first and the last to get that top number. Okay? Let's do another one. See how you do by yourself. Here it is, example 9. We got 2x squared plus 9x plus 10. 2x squared plus 9x plus 10. All right, let's see. Get us started, please. Who haven't we called on in a while? Anthony D. Pick someone. Brandon Felix. What is the first 2 things we check for? Let's go. Standard form, is it in standard form? Yes. Is there a GCF? No. Therefore, pass someone, please. Martin, what goes on top? 20. Hands if you got 20. That is correct. Once again, how do we get that? The 2 times the 10 goes on top. Then 9 underneath. Therefore, tell your neighbor what 2 numbers multiplied to give me 20, that when you add them, give us 9. Tell your neighbor, please. All right. Brandon Doherty, which ones? 4 and 5. Hands if you got that. All right. I'll give you a little bit of time so you can finish up. Go. All right. I think we got it, yes? All right. Help me out, Trinity. What do I do? Yeah, bring the 2x squared down, the 10 down, and instead of the 9x, what do I write? Plus 4x plus 5x. Hands if you got it to right there. Okay, good. From there, we group group. All right, Jaylene, what was GCF for these two right here? Both of them have x, okay. However, can both of them be divided by a certain number? 2. Hands if you got 2x. All right. So that leaves us with the x, and this one, 4x divided by 2x is 2. So far so good, yeah? Yes, Mr. Q, we love these. All right. Plus, GCF for these two, everyone. Everyone. 5, and we're left with x plus 2. Therefore, what's the same here and here? X plus 2. And what's left over? The 2x plus the 5. 2x plus 5. And these are my factors. How many of them? 2 of them. From 1 to 5, how comfortable are you with this? So what's the only thing that changes? Multiply the leading coefficient times the constant, or times the n. Okay? I think we got this, yes? Should we do another one, or we got it? All right. Move on. All right. Because I was going to give you that's an easy one. So tell you never what number would go on top, which one goes on the bottom. Number that goes on top. $24, yes. And on the bottom, 10. What two numbers multiplied to give me 24 that when you add them give us 10? 4 and 6, 6 and 4, yes? All right, we got it. Okay, so that brings us to our next section. Look up, please. Writing utensils down. I'm going to pause the music just so that we can focus. Here goes this part. I don't want to say it's challenging, but some of us have problems seeing certain things. I just want to make sure that I bring it to your attention. So from the first 3 properties that I give you, identities, the last one is something that we call difference of squares. Let me show you. This last one, this one right here, is known as difference of squares. And you're like, why difference, Mr. Q? Well, look up. Difference meaning subtraction. Squares meaning that you can take the square root of this one and this one because they are squares. So what would be the square root of that one? X and x. What would be the square root of that one? Y and y. And when there's a subtraction, one of them has to be plus, the other one has to be minus. Okay? However, today I'm introducing some new ones aside from that one. So the new ones are, before I do, look up, those. Question, look up. If these are called difference of squares, what are these called? Tell your neighbor, what are these called? Difference of squares, and these are difference of cubes. That is correct. That's what we're introducing today. So copy these. As a matter of fact, copy the last 3, these last 3. We're going to focus on these, on this last section of the session. Copy those. I'll give you some time and go. All right, so once again, we already have the first 3 identities. I'm introducing 2 more. And basically, all it is that, once again, they're shortcuts. These are difference of squares, difference of cubes. And if this is difference of cubes, this is addition, which is sum of cubes, sum of cubes. And we're going to be looking at those in a little bit. But let me just elaborate on difference of squares and difference of cubes. I'll bring them up in a little bit so you guys can see them again. So here goes. Look up to the screen. Just to clarify, what makes a square number a square number? Well, anything that makes the area a square. So if you take a number such as 3, if this is a square, that means 3 times 3 is what? 9. 9 is a squared number. What number is a squared number? 9. So how can we find its root, or where it came from? By taking square root. What does that mean? A number times itself. How many times? 2 times. Are we there? Therefore, with that same idea, what makes a cube number a cube number? A number being multiplied by 3 dimensions, not only length and width, but also depth. So check this out. 3 times 3 times, now this length right here is 3. So what is 3 times 3 times 3? That is 27. That means that the 27 is a what? Cube number. So how can we find where that cube number came from? By doing this. Look up. Not square roots. I'm going to put a little index here. This is called a what? Index. For those of you that forgot. And this is saying what number times itself how many times? 3 times. What number times itself 3 times gives us this cube number? So that number is 3 times 3 times 3. So this is 3. Some of you are saying, Mr. Q, how come this one doesn't have a 2 there? Because it's the basic root that we take, which is of 2 dimensions. That's why we don't write the little 2 there. All right. So, question. Look up. What would be cube root of 8? Talk to your neighbor. Let them know what the cube root of 8 is. Cube root of 8. Which means what number times itself 3 times itself gives us 8. Everyone? 2. 2 times 2 times 2 is 8. Okay? And with the squares, squared. So with that said, copy this one. Example 10. 18x squared y minus 50y. 18x squared y minus 50y. $18x squared y minus 50y. I left the identities on the right-hand side because we're going to refer to them in a little bit. But let's get started with the first 2 steps. So you remember the first 2 steps we test for. Standard form and GCF. Is it in standard form? Yes, highest degree to lowest. Is there a GCF? What is the same here and here? A y. Okay, so far so good. What else? Look at the numbers. What can we divide 18 that we can divide 50? 2? Can we divide 18 by 2? How about 50? 3? Just the 18, not the 50. 4? No. 5? No. So it's just 2. All right, so here we go. We took out the y for both terms, so let's see what do we have on the first term. What is 18x squared divided by 2? 9x squared, yes. What is, minus. What is 50 divided by 2? 25, okay? All right? Now, this is a trinomial. Can we use the Power Rangers? No, we can only use that for the trinomial. Now, check this out. Does this look kind of triggering your noodle? Is there anything that triggers your noodle looking at this? The minus, yes. What else? The square. So what could this be? What could this be? Difference of squares. Let's check. Here we go. How do we check, Mr. Q? Well, can we take the square root of the first term? What is square root of 9x squared? 3, and what else? X. So let's write that in 2 different parentheses. 3x and 3x, okay? Let's see if the second one works. What is square root of 25? Everyone? 5 and 5. And if it has a minus here, then that means one of them is positive and the other one is negative. But don't forget who? The 2y. These are my factors. And once again, I'm just using this pattern. If it's like this, I make two parentheses, one positive and one negative. Okay. All right, let's do another one. Copy this. Example 1. Went back to 1. Negative 3x to the fourth plus 24x. All right, let's do this one together. Is it in standard form? Yes. Is there a GCF? What divides negative 3? That divides 24. 3, since this one has a negative, so it's negative 3. What else do both of them have in common? An x, yes. All right. So, negative 3 divided by negative 3 is 1. We took out 1x, so that leaves us with x cubed. For the second one, we took out the x, it's right there. So what is 24 divided by negative 3? Negative 8. Look at it. Does this one trigger your noodle? A negative and a what? A cube. Let's look at the identities. Does it look like any of these? A negative and a cube. Okay. So let's see. If this is the pattern we're going to follow for this, that means we x is x, but this one we need to break down a little bit more. Check this out. For this one, cube root of x cubed is what? X. Okay. Cube root of 8. What is cube root of 8, everyone? 2. So that means that if we follow this identity, let's write it underneath. Let's write x cubed minus y cubed. The pattern is x minus y times x squared plus xy plus y squared. So instead of x, what are we going to use? Well, it's still x, okay. Instead of y, what are we going to use, everyone? The 2, right? Because we already got the cubed. All right, so instead of y, we're going to use 2. So here we go. X, 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 2, 2, and 2. So, squared plus times and squared. And this is one of those, like I said, it's a little bit, could be a little bit overwhelming, but if you follow the pattern after you do the cube for each of these, you'll be fine. So, can we simplify the first parentheses? No, x minus 2, it stays the same. Times, what is x to the second power? X to the second. What is x times 2? 2x. And what is 2 squared? 4. And these are my factors. 1, 2. All right, so question. Tell your neighbor, what's the only one, where is the only part that you're going to find challenging from this process right here for the cubes? Where's the only part that you're going to see kind of like you need to remember? Something to remember. Yeah, put an asterisk, put a heart, and then write, remember to take the cube root. To take, and then point to this part and that part. You need to do that part in order to find out what x is and what y is. Okay, let's do one more. One more just to make sure we get another practice here. Copy this one. 2x cubed minus 54. 2x cubed minus 54. 2x cubed minus 54. All right, first two steps. Is it in standard form? Yes. Is there a GCF? Yeah, what is it? 2. And that leaves us with x cubed minus 27. Is something triggering your noodle? Yes, the minus. So what do? Check for a cube root. So can we take the cube root of x cubed? That leaves us with x. Okay. What else do I do? Cube root of 27. What number times itself 3 times gives us 27? 3. So that means that our y is 3 and our x is s when we use this pattern. X minus y, x squared plus xy plus y squared. So, here it goes. For my x, I leave it as x. For my y, instead of 27, I use what? 3, 3, 3, and 3. And then just simplify. Here we go. So my factors are x minus 3. X to the second power is x squared. 3 times x is 3x. And 3 times 3 is 9. And these are my factors. From 1 to 5, how comfortable are you with this so far? 4, 5, 4, 4, 4. Okay. You just need practice. Yeah? We'll stop right there. So, make sure you have your code for the home play. And practice, please. Tomorrow we're moving on. Have a good one. See you guys tomorrow. Bye.